the definition of a group, then some important properties like here we have discussed that in a group, the identity element is inverse of each A belongs to G. That means is a unit. That means if you have an element, if you select an element from that particular group, you will get an unique inverse of that element. And next, the double inverse of any element of that group is same as the element. Next, AB whole inverse is equals to B inverse into A inverse. And last one, we have to discuss the cancellation laws of group theory. Okay. So today we will discuss a new topic, the semi-groups. Now this semi-group, so as the name itself gives the definition, it is a semi-group. That means you can have an idea that this semi-group are satisfying some properties of a group. Because now tell me, how many properties must be satisfied by a set to form a group? How many properties? The first day itself we have to discuss the properties. How many properties a set has to be satisfied? Hello? Yes. Four properties a set has to be satisfied to form a group. Now for semi-group. So the definition of a semi-group is a non-empty set G together with a binary composition star, or you can say as a dot, is called a semi-group if A dot within bracket B dot C is equals to A dot B dot C. That means for a semi-group, that particular set must satisfy only one condition, that is the associative property. Okay, if a set satisfies the associative property under a binary composition, then it will form a semi-group. We will call it as semi-group. Okay. Next, we have a definition of a monoid. Now, what is a monoid? So, a monoid is a semi-group which has an identity element. Now, the definition is like a monoid is a semi-group which has an identity element. Now, tell me, for a monoid, what are the properties has to be satisfied by the set G? So, how many properties? Okay, tell me how many properties it has to be satisfied. First one is the associative property, and next existence of identity. That means if a semi-group has an identity element, then we call the particular semi-group as a monoid. Okay. So always remember, for a semi-group there is only one condition, that is the associative property, and for monoid there are two conditions: associative property with the existence of an identity. Okay. So this is from these two definitions, there may be one question like what is the difference between semi-group and monoid? So you will have four options. So you have to say, okay, the correct option will be the existence of an identity. So this is the difference between a semi-group and a monoid. So next we will discuss about subgroups. Okay. Now see, here I am giving you only the definitions, because definitions and theorems from this part is important. So first of all, we will discuss the definition, then we will discuss some MCQ, then we will discuss the problems or the theorems from this part. Okay. So next we will discuss about the semi-group. So a semi-group, the definition says that a non-empty subset is. Now see, from the very beginning, that means from the beginning of a group, we are saying that for a group we must have a non-empty subset. Then only we will defined, or we will form a group. Okay. So here also a non-empty subset H of a group G is said to be a subgroup of G if H forms a group under the binary composition of a G. So now suppose you have a group G, that means S non-empty set G satisfying the four conditions. Okay, the closure property. Next, what is the next condition for a group? What is the next condition? Remember the next four conditions of a group.
Associative.
Yes, first one is the closure, then associative, then next the existence of an identity, and the last one is the existence of an inverse. Now suppose G is a group satisfying the four properties. Now as G is a set, so G must have some subsets. Okay, from those subsets we are selecting the arbitrary subset H. Now H will become a subgroup if H itself satisfies the four conditions under the same binary composition of G. Then we will say that H is a subgroup of G. Okay. So always remember, for a subgroup there must be a subset of a G which satisfies the four conditions of a group. Okay. So next, if you have a subgroup H of G, and for this subgroup H again you have a subgroup as a K. So here it is written that if H is a subgroup of G and K is a subgroup of H, then it is obvious that A is also a subgroup of G. Now can you give me the justification for this line? Anyone can give me the justification for this line? Why K is also a subgroup of a G?
A relation. They are intersecting each other.
Yes, because see, if there is a subgroup H of a G and this K is again a subgroup of H, ultimately see, this K is a subgroup of G. Okay, so if A is a subgroup of G and satisfies the four conditions of a group, then yes, again we can say that A is also a subgroup of G. So always remember this line. These are important for your MCQ. Okay, I am repeating. These are important for your MCQs. So always remember that if H is a subgroup of a G and K is a subgroup of H, then K is also a subgroup of G. So next is our so here today we have done the definition of semi-group, then monoid and subgroup. Okay. So can anyone tell me the definition of a semi-group? Anyone? What is the condition to satisfy to form a semi-group? Yes, a non-empty set, if it satisfies the associative property, then we call it as a semi-group. Now, what is a monoid? A semi-group which has an identity element called as a monoid. Okay. Now, what is a subgroup? A non-empty subset H of a group G is said to be a subgroup of a G if H forms a group under the binary composition of a G. Okay. So these are the definitions of a semi-group, monoid and subgroup. So let's see some examples, some MCQs on this topic. Okay. So here, so first MCQ is the set of all real numbers under the usual multiplication operation is
Thank you, ma'am.
not a group. So here the statement is given that the set of all real
The
numbers.
screen is black, ma'am.
Screen is black. Okay. Now is it visible? Is it visible?
Yes, ma'am. Now it is. Yes.
So here it says that the set of all real numbers under the usual multiplication is not a group. So the real numbers under multiplication is not forming a group. But why it is not a group? See, in real numbers multiplication. So first of all, you have to verify for the four properties. So first one is if you multiply two real numbers, yes, we will get a real number. So closure property is satisfied. Okay. Now you go for the second property, that is the associative property. Now tell me the set of real numbers under multiplication will satisfy the associative property or not? That means if you multiply three real numbers, you will get the same number that irrespective to the order of the numbers. Is it correct? If you multiply, suppose for example, if you multiply 2, 3 and 5, you will get 30. Now if you multiply 5, 3 and 2, again you will get 30. That means the second condition, that means the associative property is also satisfied by the real number. Now go for the third property. What is the third property for a group?
Existence of
Existence of
identity.
identity. Okay. So for multiplication, what is the identity element? That means we have to look for an element or number, real number. When we multiply that particular number to any real number, we will get the same number. So what is the identity element for real numbers?
One.
1. Yes. That means
One.
yes, we
One.
have an the identity element for set of real numbers under multiplication. Okay. So third property is also satisfied. Now go for the fourth property or the last property. Now what is the last property?
Existence of inverse.
Yes, the existence of an inverse. Now tell me, for every real number, will you get a either inverse? For every real number, we are getting inverse. Is it true?
No, ma'am.
No. Why it is not true?
Zero has no multiplicative
Yes,
inverse.
because 0 has no multiplicative inverse. So which is the correct option from the options A, B, C and D?
D.
D,
Zero.
because here it is written that 0 has no inverse. So the line should be more explicit. They have written that 0 has no multiplicative inverse. Okay. Now let's verify the answer. Yes, the correct answer is option D, and the explanation is here it is given that the multiplicative identity is 1 and the additive identity is 0. That's right. Answer is 0 has no inverse. Okay. So we have already discussed that 0 has no multiplicative inverse. That means the set of real numbers will not satisfy the property of a group. That's why it is not a group. Okay. Is it clear, all of you?
Yes. Yes.
So next one, if G dot, that means this group G and the binary operation is a multiplication, is a group such that A B minus 1 is equals to A minus 1 into B minus 1 for all A B belongs to capital T. Then G is an or A. What type of group G is? The options are a commutative semi-group, an abelian group, non-abelian group, and none of these. So, do you have any idea of what type of group G is? The definition is given A B minus 1 is equals to A minus 1 into B minus 1. So here it is given that the correct option is option B, that is it is an abelian group. Okay. Now let's see why it is an abelian group. Because for abelian group, the set must have satisfied the four or five conditions. How many conditions a set has to satisfy for an abelian group?
Five. Five.
Five conditions, because for four conditions to become a group and the last fifth conditions to become an abelian group. Okay, so let's see, the explanation is given. Okay, here there is a printing mistake. Okay, this is a b to the power minus 1, but it seems there is written a b minus 1. The actual form is a b to the power minus 1. So here is written, the solution is given. A group G is a abelian if and only if AB to the power minus 1 is equals to A to the power minus 1 into B to the power minus 1, for all AB belongs to G. Now let's see the proof. So here, first let's compute AB whole to the power minus 1 without any assumption, that is just using the basic properties of a group. Okay? That means, suppose AB is a particular element of the group G, then there must be an element X such that X into AB is equals to E, because E is the identity element. Okay. Now we need to solve for X. Now from here you have to find the value of X. So we will write like this: X into AB is equals to E, the identity element. Okay. Now X into AB, here in the both side I have multiplied b to the power minus 1. So here also X into A into B into b to the power minus 1. So we have to multiply b to the power minus 1 and right side also. Okay. So here, after multiplying b to the power minus 1 to both sides, we will get x into a, because b and minus b to the power minus 1 will be cancelled. So we will get x a is equals to b to the power minus 1. But why we are getting b to the power minus 1? Because in the right hand side we have e into b to the power minus 1. Because E is the identity element, and if you multiply any other element to the identity element, again you will get the same element. So that's why after this line we are getting x into A is equals to b to the power minus 1. Okay. Now in the next step, what I have done, the both side I have multiplied a to the power minus 1. Now it has become like x into a into a to the power minus 1 is equals to b to the power minus 1 into a to the power minus 1. Now, here see, from this to a into a to the power minus 1, again we will get only x in the left hand side. Now the right hand side becomes b to the power minus 1 into a to the power minus 1. That means the value of x is b to the power minus 1 into a to the power minus 1. Now tell me, are you clear about this portion? Are you clear, all of you? Hello? All of you are clear about this
Yes, ma'am.
part? See, if you have any doubts, please let me know. I will explain. Okay. So next is, so here we have got that a b whole to the power minus 1 is equals to b to the power minus 1 into a to the power minus 1. Now, the next part. If G is an abelian group, then G must satisfy that a b whole to the power minus 1 is equals to b to the power minus 1 into a to the power minus 1 is equals to a to the power minus 1 into b to the power minus 1. As A is G is an abelian group, that means implies you can say that G satisfies the commutative law. That means A into B is equals to B into A. So here I have written B inverse into A inverse is equals to A inverse into B inverse. Okay, is it clear? So here we are getting that AB whole inverse is equals to A inverse into B inverse. So in the next page they have written that now if we assume that AB whole inverse, see this theorem is the statement of the theorem is a group G is abelian if and only if. If and only if means first of all you have to assume this part, then you have to show that G is abelian. Again, if G is abelian, then you have to show that this part is true. So if and only if, that means you have to prove the converse part also. So here is the converse part. It's given that if we assume that AB whole inverse is equals to A inverse into B inverse, then we have B inverse into A inverse is equals to A inverse into B inverse, because this one is, see this part from the definition of a group we know that in the last class we have done that property that if AB whole inverse is equals to B inverse into A inverse. But as we have assumed that this is equals to A inverse B inverse, so I can write A B inverse A inverse is equals to A inverse B inverse. Okay? And so we can argue as follows that this is then with this line for both sides I have multiplied B. So B into B inverse A inverse is equals to B into A inverse B inverse. Now by cancelling this B and B inverse I will get A inverse on the left hand side, and the right hand side I can change this one as a B A inverse B inverse. Now again from this line with this line, what I have done, I have multiplied A into the both sides. So here I am writing A into A inverse is equals to A into B A inverse B inverse. Now this A and A inverse will get cancelled, and I can write the identity element E. And the right hand side will become as a AB into A inverse B inverse. Okay. So again, the next step, I have multiplied B to both sides, that is left hand side and right hand side. Again, I will get B is equals to A, B, A inverse. So again, here I have multiplied A to both sides and I am getting A, B, B, A is equals to A, B, A inverse A. So here, B, A is equals to A. That means the group G satisfies the commutative law and hence it is an abelian group. Now I know that I think most of you have not understand this part. So I will do one thing. I will share this PDF with you. Please go through this theorem, this statement. It is easy. You will understand. Okay. Okay.
Ma'am.
So here the correct option is the this G is an abelian group. Okay. Next example. Now, in the next example, if G dot is a group such that A square is equals to E for all A belongs to capital G, then G is a what type of group? Semi-group, abelian group, non-abelian, none of this. So, our definition is A square is equals to E. So, the main thing is you have to look for those four properties. Now, if A square equals to E, can we say that is it a closure property? Satisfy the closure property? If A square is equals to E, it will satisfy the closure property or not? See, the closure property means if multiply or if you add any two elements from that particular set G, you will get the product in the same set G. Okay? Now, if A square is equals to E, where E is the identity element, now this E is always in G. Okay. That means if you take any element A in place of A, you can take B also, you can take C also, then you will get E. That means A square or B square is again in G. So in this way we can say that G satisfies the closure property. Okay. Now go for the associative property. What is the associative property? If you take three elements A, B and C, the product will be AB into C is equals to A into BC. Now, for that particular set G, will G satisfy the associative property?
Yes.
Yes. G satisfies the associative property or not? Yes, it will satisfy the
It's
associative
satisfied.
property. Yes. Then go for the third property. Existence of identity. Yes, we have an identity element E. So third property is also true. Then go for the fourth property. The existence of equal. Will you get the inverse?
Yes.
Yes. Then so four properties are already satisfied. That means it is a group. So if it is a group, then option A and option B is already gone. We will not select this option A and option B. Okay. Now left is option B and C. That means abelian and non-abelian. So we will go for the fifth property. That is the commutative property. Now let's see the commutative property. What is A square into B square? If you take two elements A and B, now calculate A square into B square. Okay? What is the value of A square? E. So in place of A square, you can write E. Now again in place of B square, you will write E. So after A square into B square, you will get E into E, which is equals to E. Okay? Now multiply B square into A square. What you will get if you multiply is B square into A square.
E.
E. That means see A square into B square is equals to B square into A square is equals to E. That means that particular group satisfies the abelian or the commutative law. That's why it is an abelian group. So that's why the correct option is given as a B. Okay? The correct option is option B. So in this way, see, here what I have done, I have just typed on the MCQs on the set group theory. Okay, in this way you can find many other MCQs also on the group theory. So you just practice those MCQs. Okay, the answers are already given in your in that page only. You will get the answer. In some MCQs, the explanation or the discussion is not given. So if you have any doubt, so we can discuss in our class or you will share it in our group. So we will discuss. Okay. So you just find the MCQ, you just solve those MCQs. Okay. So here I will stop the topic group. In the next week, I will stop. I will start the next topic, which is greens. Okay. So before Monday, you just go through all the definitions of group, semi-group, subgroup, monoid. Okay. So these are important points you have to remember. And all the MCQs will be on that.
Share this one, ma'am.
Hello.
Can you this? Can you share this one?
This MCQ page.
Yes, ma'am.
Okay, okay. I will share in our group. So you just go through that MCQ and I will share the PDF also. Okay. So I will stop here for today.